Good morning, everybody. As soon as you're settled, go ahead and look at the slide on the board. Post one unique thing in the chat, big or small, one unique thing. Welcome to today. Yep, good morning. All right, 60 seconds. 5 seconds. Great, let's look through that chat. Good, I see a lot of good information in there. Yep. All right, so what did we talk about? Yes, it is a methane combustion reaction. It's balanced. One of you noticed that we have the products over here, but water is a gas, whereas on the very bottom, the water is a liquid. So the difference between carbon dioxide and water when it's a gas to carbon dioxide and water when it's a liquid, and there's 2 moles of water, that's how we got that change in enthalpy right there. Somebody said that, yes, there's red arrows going down. Yep, negative exothermic. This reaction here is negative 890. Same thing we did last week when we're calculating enthalpies. Same thing here, negative 802. And that's just this portion. So that's why it's stopping here, because that first arrow stops when it's a gas. The second one is just going for the gas to the liquid, as we said. And see, anybody notice that if we added up H2 and H3, it equaled H1, but it does. Negative 802 plus negative 880 equals negative 890 kilojoules. So that energy there from our reaction can be compared. The parts can be added up into the whole. Yep, you're right. Just like the lab, when we did sodium hydroxide pellets versus sodium hydroxide aqueous, neutralizing with hydrochloric acid. We didn't do this picture form, okay? And we didn't do the form that I'm going to show you next, but I visually walked you or physically walked you through that lab of adding up those parts. Yeah, it'd be nice if we could do that in real life too, but that lab gave us a good approximation. All right, so over here, same thing. It's just reminding delta H1 is equal to the sum of delta H2 and 3. Okay? And that is Hess's Law. That's what we're learning about today. Go ahead and 1 minute and write down the information from the slide. Okay, 5 more seconds. Oh, okay, 15 more seconds, no problem. Okay. All right, so Hess's Law, the enthalpy change, delta H for any chemical reaction is the same whether reaction takes place in one step or multiple steps. And it's exactly what we just talked about. I just wanted you to get the official definition down, flashcard that so that it's readily available when you need it. And this just kind of rewrites it. The sum of each of the intermediate steps is equal to the final reaction. And we haven't done a lot with intermediaries, but we will. And that'll make more sense why I called them out differently now. Okay. Reactions can be manipulated as long as whatever you do to the reaction, you also do to the delta H. And here's my little hint down here if nobody had posted in the chat about it. We did this already, so you're already familiar with it a little bit. We're just going to now show it to you in this type of format. Our goal, nitrogen gas and oxygen gas equal nitrogen dioxide. And they gave us our endothermic enthalpy right there. And this can be broken down into 2 parts. Anybody see anything interesting about those 2 equations? One, yeah, I didn't write state symbols. I should have written state symbols down because sometimes you do need that. In this case, we don't need it, but that would be a good thing for you to always write down. Okay. Nitrogen gas and oxygen gas give you nitrogen monoxide. Nitrogen monoxide's on the left and the right. So if I'm adding these 2 equations together, I actually can cancel them. Not if they're separate. If they're separate, 180, negative 112. But if I'm adding them together to find the goal, nitrogen monoxide is on the left side of the yield, or like the left side of the equal sign, and the right, so I can cancel it out. What's left? 1 mole of nitrogen gas, 2 moles of oxygen gas. and 2 moles of nitrogen dioxide. So we just added these two equations. So we have to add the H1 and the H2. 180 plus a negative 112 is 68. I know that was fast. Don't worry, we're going to do it on the Jamboard so you can see it with another reaction a little bit slower, and then you'll have some practice time. Our goal was the overall reaction. We added these guys up. It's on both sides, it gets canceled. It gets on the same side, it gets added. Same thing. Okay. All right, 2 rules. If you reverse a chemical reaction, you also convert and reverse the enthalpy. Does that make sense? Yeah, because our forward reaction is exothermic, then our reverse reaction would be endothermic. Yeah, you've done this before. Okay, and then this time I did remember all my little state symbols there. What's another question we usually get? I just put it right there just to make sure we covered it. Why is there a half? You tell us never to put half. In this case, I needed to know 1 mole. So if I needed to know 1 mole of sodium chloride for my comparison or for my reaction, then yes, then half is okay. Rule 2. If you have to multiply or divide to meet your goal, you have to multiply or divide with your enthalpy. My enthalpy is times 2. That means all my coefficients have been times by 2. 2 moles of sodium instead of 1. 1 mole of chlorine instead of a half. 2 moles of sodium chloride instead of 1. Negative 822 instead of negative 411. So those are our 2 rules. We're going to go through and we're going to do this reaction. Here it is typed out so you can see it a little bit clearer. I'm going to go over to the Jamboard now where I've written it down. So how do we approach these? Remember, we're adding them up together to get to the goal. So I always start by trying to find each of these guys in the steps. N2, where is N2? Is it in the first equation? Nope. Is it in the second equation? Yes. Is it in the third equation? No. And notice this one's not really intermediary as what we had before. That's okay. It still works on the same process. You can have 3 separate reactions that you want to find your goal. Why would I want to do that? Because maybe this reaction is a real pain to do in the lab. And it's a lot faster if I do the partial reactions. So the only place that I have N2 is in the second equation. Always find the ones that are singles first. But there's a problem. Anybody see the problem? Yep. He's on the wrong side. What was rule 1? Switch the reaction. I know what you guys want to do. You want to just go, okay, negative 82.5, I'm done. It's great that you remember the negative sign, but do not do that to yourself, because when we get to the canceling part, you're going to make a mistake and then you're going to have to start all over again. Yes, you are switching it. You are not doing a multiplication because 1 mole is 1 mole. So you can just do directly switching around the reaction so that it's exothermic. But physically write it. 1 N2 gas plus 2 O2 gas yields 2 NO2 gas. And yes, state symbols for these ones, very critical in case we have any type of situation going on where you have to cancel the gases and the liquids. I don't know if we have that in this one yet, but just keep in mind, write it completely out with state symbols. And then circle it if you meet your goal. It's like a target. Picture a target. Okay? 1 mole of N2, 1 mole of N2, both in gas form, both on the reactant side. Yes, that guy is taken care of. Okay? Make sure you don't have any transcription errors when you did that writing. And if you do, or if you don't, just put a single line through it, just in case you have to go back to it later. But you don't want to accidentally double cancel things out because it's on the wrong side, because we flipped it, remember? Okay, H2. Is there any H2 in that first reaction? Yes. Any H2 in my new second reaction? Nope. Any H2 in my third? It's a double. It shows up twice. So we have to deal with it twice. Let's go on. Okay, because sometimes just doing the last one helps us solve our problem. Ammonia. Ammonia is in the first. It's not in the second. It's not in the third. So I'm going to deal with ammonia first. How many moles? 2 moles with it as a gas. 2 moles as a gas. Oh, I don't have to do anything with that guy. He's already facing the right direction. They're both on the product side. They're both the direction we want, both the number of moles. So again, I don't need to reverse this reaction because it has the ammonia in both products. So I'm going to box that there. And actually, I probably should go back and box this just so that I can know it. Okay? Reaction 1, reaction 2. So we now have H1 and H2. Okay? But in this case, we have 3 reactions. So I'm going to actually need H1 plus H2 plus H3 equals our goal. Okay? You could have as many as they give you. Just make sure that you are adjusting every equation and then canceling at the end. All right, so I saved this one for last to make sure that I am almost done and I don't have to worry about what else is going on. If I hadn't saved H2 for last, I might have mixed up what I needed to do with this. Maybe I divided wrong because I saw the H2 needed to be 3. Well, that would have messed up my 2 moles of NH3. So this equation is not going to be changed now. It is now in its finished form. I want 2 moles. It's going to stay like that. This guy is in its finished form. I want 1 mole of nitrogen. But I need to get 3 moles of hydrogen gas on the left side. Okay, are they all gases? Yes, both hydrogens are gases, so I don't have to deal with any of that, which makes sense because it's hydrogen, right? I need to get 3 moles on the left. I have 7 moles on the left and 1 mole on the right. Any ideas? What do I need to get? Think about your goal. I need to get 3. And we're not going to divide here because I have stuff on the left and on the right. So if I have 7 moles on the left, 1 mole on the right, if I were to simplify that, I would end up with 6 moles. Okay? So that's not what I want, right? I want to have 4 moles. So what can I do to this number? Something times x plus 7 equals 3. Oh, actually, that would actually be a minus. I can't talk. Okay, 7H2 minus something times this hydrogen is equal to a 3. That means 7 minus 4 is 3. So I need 4 hydrogens there. How do I get 4? I multiply times 2. Multiply times 4. So I now have 4 hydrogens liquid yields 4 hydrogens gas plus 4 times 1/2 or 2 oxygens gas. So now I have my 3 equations there. Negative 43.7. What do I need to do with it? Same thing. Yes, exactly. You guys got it. I need to multiply negative 43 times 7 times 4. Okay. And when I do that, then I'm going to be able to see what cancels. Did I get what I wanted, my 3? 7 minus 4 is 3. So both of those guys are going to be going into helping my goal. So I tend to put a target on one side and then a target with what was subtracted on the other. 7 minus 4 is 3. So I now have my goal. Now you can stop here, but I tend to have math errors. So I would have you keep going. Okay? Let's make sure I can actually add things up properly when I do this. I have 4 waters on the left side. I have 4 waters on the right side. Oh, and you know what I didn't do? What did I tell you to always do? When you have no transcription errors, go ahead and put a line through there so you don't accidentally use the wrong information. 4 waters and 4 waters. So those are going to go get canceled because they're on both sides. Okay. What else do I have? 2 oxygens. That one's on the left, and 2 oxygens, that's on the right. So those guys cancel. What am I left with? 2 nitrogen dioxides, 2 nitrogen dioxides. By canceling all these, now I can go back and say, okay, do I have any errors? I have everything either targeted or X'd off. Targeted or X'd off. Targeted or X'd off. Phew, I made it. What do I then have to do? I still have to do the math of the problem. Okay? 142.5, I'm going to put this on the next page. 142.5 plus negative 82.5 plus negative 43.7 times 4. So I'm going to plug that all into the calculator. Go ahead and plug it in yours as well. 30 seconds. Let's see if we all agree and we all plugged in our positives and negatives correctly. And I got negative 114.8 kilojoules would be my enthalpy change of the total or the goal reaction or the overall reaction. Okay, any questions on that part? I'll go back to the last slide. Yeah, just in a second. Just everybody understood how I added up all these? Okay, let me go back over here. Any questions over here? Okay, yep. We're going to do one more example problem, and then you guys are going to help me walk